Hey Algebra 1, and thanks for tuning in. Today we're going to be looking at lesson 7.4, factoring using the GCF. It's basically undistributing, so what we learned back in the previous lessons of chapter 7 where we're multiplying polynomials, we're just going and taking that step back and working backwards there. We're going to be looking for 6 things in our notes today, so let's go ahead and get started first. First thing we want to think about is how can we simplify this polynomial. So what I'm going to go and do is get you to pause the video here and try to simplify the polynomial. Basically, how would you distribute the outside term to everything on the inside? So let's go ahead and pause the video now, try it on your own, and then click play when you're ready to check. Alright, so what you should have done was distributed the 2x squared to both the x and the 2. 2x squared times x will give us 2x to the third power. Because remember, if there's a variable by itself, it automatically has an exponent of a 1. And then if we did 2x squared plus 2, we're just basically multiplying the 2's together and we'll get 4x squared. So after I distributed, this would be my answer, 2x to the third plus 4x to the second. Again, here we have a little bit different of a situation here. We've got some different variables. Let's go ahead and again try to simplify the polynomial again. So let's pause here and go and distribute the outside term to everything on the inside to see what we get. Alright, so you should have distributed the 6x to the third to both the 4x and the 3y. 6x to the third times 4x. You're first going to just focus on what is 6 times 4, and that's 24. And then you have an x to the third and an x to the first, which would give you x to the fourth. Then we're going to move on to the timesing of the 3y. Again, just focus on the 6 times the 3, which is 18. And then we're going to do x to the third times y. We can't really combine those exponent numbers, so we're just going to write it as x to the third times y, just like that. So we'll have 18x to the third times y. Okay, so what we've just done is we have distributed, and we've basically just worked backwards of what we're going to see. What we're going to be looking at today is how can we undistribute. So first off, maybe think about this binomial right here. We have 3x squared plus 9x. What would you think was distributed to find this answer? So take a moment to think about what could you undistribute to make it as simple as possible. Some of you by now are like, what the heck are you talking about, Miss Mullins? Well, let's get to that on the next page. What we're going to be thinking about is how to factor polynomials. That is the title of these notes, and we're going to be using a GCF to do that. We're basically just trying to figure out what to undistribute. So first we're going to figure out the greatest common factor of the coefficients, or 3 and 9. So you can make like a factor tree. You've seen these before. Sometimes these are a little bit more confusing to others, but notice they both have a 3 in common. So the greatest common factor for both of these is 3. A lot of times I just like to list the factors to find the GCF, so I'll list the factors of 3 are 1 and 3, the factors of 9 are 1, 3, and 9, and again they both have 3 in common, so the GCF is 3. So that would be technically step 1. And then the other thing we haven't looked at, so if we factored out the 3's, then we have just focused on the coefficients. The other thing we have not looked at yet are the variables, and the variables also have a GCF. So this one, again, you would think about your factor tree or just listing the factors of them. How can we make x to the second power? Well, we make that by doing x times x. And how do we make just an x? We do x times 1 or 1 times x. Either way, their GCF is x, so we would also be factoring out that x. Another way I like to do this is, again, just think about if I have x squared and if I have x, what is the most x's that can go into both of them? And they both can fit in one of those x's in there, so that's all you can also find the GCF there. So what you're essentially going to be doing is trying to figure out how can we factor out the 3 of the coefficients and the x of the variables, and this is what that's going to look like. So when we're going to divide each starting term by the GCF of 3x. So that's basically my first term of 3x squared. I'm dividing that by 3x, and I'm going to get Just a second while my pen does not work. When you're dividing out this GCF, maybe think about just the numbers and then the variable. 3 divided by 3 just gives me 1, so you could go ahead and write the 1 down if you'd like to. And then x squared divided by x is just going to leave you with an x. So you can either say 1x or just x. Sometimes I like to write the 1 there though, because to show that I did 3 divided by 3. And then you'd also divide the 9x by 3x. 9 divided by 3 is 3, and x divided by x is just 1, so we're left with just a 3. So my answer of factoring out the GCF, you can either say 3x parentheses 1x plus 3, or 3x parentheses x plus 3. So what we've basically done is just worked backwards and trying to figure out what would it look like before I distributed. Here are some steps to consider, and this is the third thing you're going to write down in your notes for steps 1, 2, and 3. First step is you're going to find the GCF of the coefficient and the variable. So a lot of them will have variables in common, like everything might have an x in it, everything might have an x and a y in it. You just have to find out what's going to be in common for all the terms. Then step 2, you're going to divide each term by the GCF of the coefficient and variable. And then step 3 would just be writing your answer after you divided. So your GCF would be on the outside of the parentheses, and whatever your term was divided by the GCF, and then continuing on. You might have more than 2 terms, and we're going to see that here in just a moment. Let's go ahead and take time now though to pause for number 3 so you can write these steps on your own, and then click play so you can try some questions on your own. Alright, so this one's number 4 in your notes, and it says to factor out the polynomial using the GCF. So just think about again, you have to find the GCF of the coefficients, and those coefficients are 12, 8, and 4. And then you also have to find the GCF of the variables, which are x to the third, x to the second, and x. Once you find your GCF, then you can divide. So let's go ahead and pause here for number 4. Try it, and then once you're done, click play so you can see how it's done. Alright, so what I found for the coefficients of the GCF is the GCF of 12, 8, and 4 is 4. Here's the list of my factors, and notice they all have 4's in common, and 4 is the biggest number. So I know that I'm going to be dividing everything by 4. I also need to find the GCF of the variables. Basically, what is the greatest number of times that x can fit into all of these? And that would be just a 1x, because you have x squared, x to the third, those are going to be multiples, but 1x would be fitting into all of them. So I'm going to divide everything by not just 4, but 4x. Okay, I'm going to go ahead and write my GCF on the outside of my parentheses and begin. When I'm dividing out my GCF, I'm going to focus on the numbers first and then the variable. 12 divided by 4 is 3. Then I have x to the third divided by x to the first. That's just going to be x to the second. I'm just subtracting 3 minus 1, according to my exponent rules we learned a while ago. The next one, I'm going to divide 8 by 4. That's going to give me 2. And then x squared minus x to the first. That'll just be x. The last one, I'm basically just dividing 4x by itself, which is going to give me 1 as my answer. So my factored out polynomial is 4x, parentheses, 3x squared plus 2x plus 1. Remember, you can check your work by just distributing again. Once you distribute, if you get the same answer as what you started with, you know that your answer is correct. So that's another way that you can always check your work. 4x times 3x squared is 12x cubed. 4x times 2x is 8x squared. And 4x times 1 is 4x. So here we go. Let's go ahead and try maybe a shorter one for number 5. Our polynomial is 5x to the fourth plus 10x to the third. Let's go ahead and pause here, factor out using the GCF, and then click play when you're ready to check. Alright, so my GCF is going to be 5 for the numbers, And then for the variables, it'll be x to the third, because x to the third can fit into both x to the third and x to the fourth. Now I'm ready to divide all of my terms by 5x to the third. So what I'm going to do is go ahead and just write underneath each one, divide by 5x to the third. And I'm going to start with my numbers. 5 divided by 5 is 1, so you can write the 1 down if you'd like to, just to remember that you did divide the numbers. And then x to the fourth divided by x to the third is going to give me x to the first, or just x. The next one, I'm going to go ahead and divide my numbers again. 10 divided by 5 is 2. And then x to the third divided by x to the third is just going to cancel out. It's going to give me x to the 0 or 1. So I can write my answer as 5x to the third, parentheses, x plus 2. Again, you can go back and check by redistributing. 5x to the third times 1x is 5x to the fourth. And 5x to the third times 2 is 10x cubed. The last one, let's go ahead and try this one more time. Let's see what our GCF is, factor out the GCF, and then click play to check your work. Alright, so what I noticed about all these numbers, 3, 18, and 24, is they all have the number 3 in common. Then I looked at my variables. I have x to the 6th, x to the 5th, x to the 4th. Noticing that the greatest number that can go into all three of these is x to the 4th. So my GCF is 3x to the 4th. Now I'm ready to go ahead and divide everything by 3x to the 4th. Alright, starting with my numbers again. 3 divided by 3 is 1. So I'm going to write my 1 just to make sure I wrote it and divided correctly. And then x to the 6th minus x to the 4th is x to the 2nd. Next up, I have 18 divided by 3, which is 6. And then x to the 5th divided by x to the 4th, or just subtract 5 and 4, and I get 1. So you can write 6x to the 1st, or just 6x. And then the last one, I have 24 divided by 3, which is 8. And then x to the 4th divided by x to the 4th, or subtracting, both give you 0, so that's going to give you 1, which means my answer is 3x to the 4th, parentheses, x to the 2nd, plus 6x plus 8. And I went ahead and just erased those 1s that I had for exponents and for coefficients. Okay? That's going to conclude our notes for today. Thank you so much for tuning in, and we'll catch you next time.